Now properties of vector product of vectors. Now see, to fix the direction of resultant vector obtained by A cross B, we use right hand screw rule or right hand thumb rule. So easily we can understand this thing. If we rotate right hand screw from A to B, then the direction in which it transfers, and if we rotate it from B to A, then the direction in which it transfers, both will be opposite. It implies that if we take A cross B and then if we take B cross A, then we will not get the same result. So we can say A cross B is not equal to B cross A. Means vector product of two vectors is not commutative. Here magnitude wise A cross B and B cross A will be same one. Magnitude wise it is A B sine theta. But direction wise exactly opposite. So we can write A cross B, that is minus B cross A. Then distributive law, that as it is we can represent. Suppose we want vector A cross vector B plus C, then simply we can write first vector A cross vector B, then plus vector A cross vector C. So we can say commutative law holds for vector product of two vectors, right? Now, if two vectors are parallel to each other or two vectors are anti-parallel to each other, so in that particular case, if parallel, then theta is 0. Then sine theta, that is equal to sine 0, that is equal to 0. So A cross B, that will be equal to 0. And if two vectors are anti-parallel, then in that case also sine theta, that is sine 180, and that is equal to 0. So if two vectors are parallel or anti-parallel, their cross product, that will be always 0. And remember this thing, when two vectors are perpendicular to each other, their dot product is 0. This thing is very important in problem solving as well as MCQ solving. Now if A and B vectors are perpendicular to each other, then sine theta, that is sine 90, that is 1. So A cross B, that is A B sine 90 n caret. So simply we can write sine 90, that is 1. So this is equal to A B n caret. Now vector product between unit vectors of Cartesian coordinate system. We know in Cartesian coordinate system, I caret, j caret and k caret unit vectors are respectively in the directions of x-axis, y-axis and z-axis. Suppose here we take I cross I, then we can write magnitude of I, that is 1, magnitude of I, that is 1, then sine theta, that is sine 0. In this case, theta will be equal to 0, sine 0, 0. So I caret cross I caret will be equal to 0. Similarly, j caret cross j caret as well as k caret cross k caret, that will be equal to 0. But suppose we take I caret cross j caret, then I caret cross j caret. So we can write here, see, suppose we consider that clockwise circle like this, okay? Then here remember, I caret cross j caret, that is equal to k caret. Why? Because magnitude of I caret is 1, magnitude of j caret is 1. I caret and j caret are perpendicular to each other, so sine theta, that is sine 90, that is 1. And in definition we have n caret. N caret, that is perpendicular to both the vectors. Here perpendicular to I caret and j caret, that is the k caret. So here we can write I cross j, that is k. Now in this way, if you think clockwise for this circle, then easily you can remember I cross j, that is k, j cross k, that is I, and k cross I, that is j. Now if you take anti-clockwise, right, then the result will be with negative sign. See here, I cross j, that is k, so j cross I, that is minus k, j cross k, that is I, so k cross j, that is minus I, k cross I, that is j, so I cross k, that is minus j, right? Now the vector product between vectors in the Cartesian component form. Okay, so in Cartesian component form we write vector A, that is equal to axi caret plus ayj caret plus az k caret, and vector B, that is equal to bxi caret plus byj caret plus bz k caret. Now vector A cross vector B, that is equal to, in first bracket we have to take vector A in the component form, cross in second bracket vector B in component form. Now here carry out this multiplication in this way. First take axi caret and multiply it with these three one by one. Okay, here the symbol of cross that will be placed between vectors only, because cross product is defined for vectors only. So first step will be ax bx I cross I. Here you have to maintain the order. These unit vectors are first, so in multiplication you have to represent this one first and then this one. So ax bx I cross I, then ax by I cross j, then ax bz I cross k, this third one. Then after sorry, second one, ay bx j cross I, then ay by j cross j, then ay bz j cross k, then third one, az bx k cross I, az by k cross j, az bz k cross k. Now see, we already discussed about the vector product between unit vectors. So substitute those values. Now we discussed that thing, I cross I, j cross j and k cross k, that is 0. So this particular term, this one and this one will be cancelled. And now substitute the values of I cross j, I cross k like this. So here I cross j, that is k, then I cross k, that is minus j, then j cross I, that is minus k, then j cross k, that is I, then k cross I, that is j, and k cross j, that is minus I. Now here take I caret common, then we will get two terms in the bracket ay bz minus az by. Then after take j caret common, so we will get az bx minus ax bz into j caret, plus now take k caret common, so ax by minus ay bx k caret. So this one is the result of A cross B. You have to remember in this particular manner this equation, or you can represent this one in the form of determinant. So vector A cross vector B, that is determinant I caret j caret k caret AX, AY, AZ, BX, BY, BZ. Now, mathematics students know what is determinant and how to solve it. But biology students don't know, right? So, if you remember in this particular manner, then you have to understand how to solve this determinant. Okay? So, see here. Now, actually in this second step, J caret is taken common. So, when we take J caret common, so AZ BX comes first, then minus AX BZ. But when we solve this determinant at that time, here J will appear with negative sign. So remember this thing, in that particular case, when you take J that is with negative sign, then AX BZ will come here first, then minus AZ BX. Now let's understand how to solve this particular determinant. See, now this one is our determinant. IJK, AX, AY, AZ, BX, BY, BZ. Now for determinant, this one is known as row, and IJK are the components of first row, AX, AY, AZ are components of second row, BX, BY, BZ that is component of third row. This one is the column. So component of first column I caret AX BX, for second column J caret AY BY, then for third column K caret AZ BZ. Now first forget about sign. Later on we will discuss about the sign plus minus. First think like this. First take this component I caret from first row and first column, right? Now this particular component appear in the first row and first column, so we have to discard this row and this column. So if we discard this one, then we will have this particular 4 components. Then we have to take product of this one, AY BZ on right side, then after minus AZ BY, like this. Clear? So I caret into AY BZ minus AZ BY, right? Now this first thing. Then after take this J caret. So J caret that is in first row and second column. So discard first row and second column. So now we will have these 4 components. So again take the product of these 2 components in right direction, then minus in left direction. So J caret into AX BZ minus AZ BX. Clear? Then after think about this third one, K caret. So discard again this first row and third column. Now we have these 4 components. So again take product in right side direction, AX BY in cross, then in left direction in cross. So K caret into AX BY minus AY BX. Clear? Now simplification is carried out. Now we have to give signs. So here represent this one with positive sign. So first positive sign, then negative sign, then positive sign, right? And math students will study further how to solve this entire one with these all 9 components, but that is beyond our scope. So clear to all of you how to solve this one?